for this week, and it's another application, and it's really just another plug and chug. So let's tell you what we're going to calculate. We're going to calculate surface area. So I want you to imagine that you've got your usual z equals f of xy, you know, flowing hill surface. And on the base, on the floor, in this case, you have a triangle. And this is your region D. And if you project that triangle up to the surface, can you imagine it would make a kind of a curved like triangular shadow, right? And we are trying to find the surface area of that. Sally, what's your question?
Wasn't there an example we were going to finish today?
There was. Well done. Is that what you were going to tell me as well, Terence?
Yes, sir. Thank you, Sally.
Well done. Okay, hold that thought. Let me just finish that thought and then we'll go back to the last one. So the surface area of this guy here, right? So it's going to be a positive number. It's a physical surface, right? It's a kind of wobbly triangle, probably. It's a double integral, and this is the formula dA. So you can do this integral in terms of xy. If this, for instance, if it's a triangle, that would probably work. If the shape on the bottom is part of a circle, you would probably use a polar form of this. Now, the question that I missed or forgot to do, I believe it was this triangle one. And let me find it. Take a few seconds. Well, maybe take me more than a few seconds. I've got too many windows open. There we go. And it was the last question on 15.4. That's what my memory tells me.
Yeah, and then there was also the one with the circles.
Oh, the circles and the circles. That is something I forgot about. I totally left my mind. Okay, let's do this first one, then do the second one. And I didn't realize I was so far behind from what I intended to do. I'll have to adjust things, but that's fine. I'll do that after, once we figure out exactly what we can and can't do. Let's do this fella first. So that's meant to say A, this is meant to say A. This is the region that we're interested in. And essentially we're being asked to find the center of mass of this shape. And what else did it tell us? It's an isosceles triangle, which is pretty obvious. And the density function is proportional to the square of the distance from the vertex to the opposite hypotenuse. Let me read that. From the vertex to the opposite hypotenuse. Oh, they must be talking about this guy. Okay, so the density function is the square of the distance. It's just the way they phrased it. Confused me. Right. Well, we don't know this guy, we don't know this guy, and we got this fella. So the double integral is going to be, oh, it is proportional. I forgot. So it's going to be k times x squared plus y squared over this region D, right? And dA, right? So if I was going to create this, I would do it, I would go vertical rectangles and scan from here to here. Now that means I need to know the equation of this line in the form of y equals. What slope is that line? Even although these are not numbers, you can still figure out the slope, which is a number.
-1.
Right. Yeah, plus a, because it crosses the y-axis. So our double integral to calculate m is going to be the integral from x equals 0 to x equals a, the integral from y equals 0, which would be here, to the top, which is why we calculated straight line, which is that guy. And the density function is k x squared plus y squared. And then I do a dy and I do a dA. Now, when you're finished with this calculation, do not be surprised that there's going to be a k and an n, right? So it might be like k times a or 2ak. So it seemed reasonable you'd expect to get an e just because of the terms. That's okay. And your answers will actually have a's in them as well. That's pretty much all I want to tell you on that, is to give you, I mean, this is question 13 and they're all the same. So this is the setup. So you know you're then going to do the mx and the my, and then you can do the x bar and the y bar. It just takes time. Now, the one that I really want to spend the time on was this circle one. So we did it in Desmos. I remember vaguely doing it in Desmos anyway. And there was a circle that looked like that, wasn't there? And then there was a circle that went something like this. And the region D was this guy. And the density function in this story was inversely proportional to the distance from the origin. So inversely proportional is k over, and it's only the distance to the origin which makes it that guy. Based on the fact that D is circular and that the density function looks like this, would you agree that this is probably going to be done in polar form?
Yes.
Right, so the density function is k over r. So I'm going to need him. Now, we need to create this fella, and that means we have this guy. And if you do a radial line, which is just any line from the origin outwards, you've got this guy and you've got this guy, and then you go this way, and you go this way, and you go this way. And so I know that R is going to go, the smallest number is the circle, the little baby circle. What is the baby circle? 9. So it's going to be 9 to some other number. And we're going to do theta. Right. Now, theta, okay, this is a blown up version. That point there and that point there, and we are trying to find this angle and this angle. And they're both numbers because it's a fixed number, right? It goes that way and it goes that way. And I believe it was 1/6 and 5/6, but I don't know if I ever proved it to you. Did I prove it, or do you want to see why I know that this theta starts at 5/6 and then it finishes at that corner? Sorry, it starts at 1/6 theta. And
I
over
did
here
the
it
math
finishes.
to find those coordinates yesterday.
Okay, so if I assume then we're good with that, the only thing that's missing is this guy, right? And what do we know about this particular circle, this outside circle, which basically means that point there, is that we know that x squared plus y squared is 18, or at least in the one I'm looking at is 18y. And I need to try and use this to come up with the figure that's going to go here. So I'm going to replace the r with r cos theta, so you get that. Replace the y with r sin theta to get that. And then have 18 and r sin theta. Are you all happy with all the x's and y's being turned to r cos or r sin? Now, that guy is going to be solved for r equals. Might not look like it's going to happen, but it's going to become r equals something. And whatever that r equals something, it's here. The inside one, right? See if you take any one of these radial lines, isn't the inside one always 9, right? So that's why that's fixed. The outside one is this fella. Is there anything on the left-hand side that you can see that we could use? What does that combine to?
R
Just
squared.
Great. Now, can we make the assumption that r equals 0 is not going to happen? This is me just being legal. And since I know r can't possibly be 0 because it has to be at least 9, I'm now going to divide both sides by r. And that's where the 18 sine theta came from. So we've got this shape, we've got a density function, we've turned the density function into a formula using R. We found that the region D is from 1/6 pi to 5/6 pi, that's theta, and that R goes from 9 to this curve, and this curve we finally found out had this equation. So the mass is going to be the integral from theta equals 1/6 pi to theta equals 5/6 pi. Then it's going to be R equals 9 to R equals this guy. The density function times R dr d theta. And I remember, I think it was Sally that said it. Terence, have you got your hand up for a question, or you forgot to put it down?
Yes, sir. Since in both cases, we know that we've got the theta values pi over 6 and 5 pi over 6. Those both have the same sine value of 1/2, and our sine values only go from 1/2 to 1. So can't we just put our, well, 18, it goes between 9 and 9. That would be why, because it goes between 9 and 9. 18 times.
So, oh, you're saying 18 times this number and 18 times that number, and on this side, 18 times this number gives you this, and 18 times that number gives you that. Is that what you're saying?
Yeah, we have a R value.
Well, what you're looking at there is really destination ones. That's little snapshots of all the things that happen as you travel around. If you did that, you would end up with the answer being 0. Which wouldn't be a good idea because it's clearly not. So I guess the answer is you're not allowed to do what you wanted because these are limits of integration. So when we say R equals 9 to R equals this guy, we mean it goes from 9, it passes through a whole load of points, and then maybe it comes back and stops somewhere else. But it does, I mean, in this case here, it does start at 9, agreed? But doesn't it get bigger and bigger and bigger and then smaller and smaller and smaller, and it finishes at 9? So what you just did is tell me what the R value at the beginning and of the end, but not the fact that it changes values as it swings round. And that's why you're not allowed to do that. Secondly, getting 0 is a bad idea for an area when it's a physical area. So that's kind of my argument for it. So we have this fella. And that cancels out to K. So I'm basically just going to get KR. Evaluated at this fella and at this fella. And then when I get that answer, we'll integrate it with theta. What's that going to get? It's going to give me 18K sine theta. Take away basically 9K. And if you integrate a sine, you get a cosine, so a negative, in fact, so you get negative 18K cosine theta, take away 9K theta, evaluated at 1/6 pi and at 5/6 pi. Are we cool with this? Right, that's going to be negative 18K times the cosine of 5/6 pi minus 9K 5/6 pi. Take away negative 18K cosine of 1/6 pi negative 9 times K times 1/6 pi. And I'm cheating here because I've got an answer in front of me. That entire horrible mess ends up being 81√3K.
Why is it 81 and not 18?
Because that's what it says on the thing that I'm looking at here. So I don't know. Do you think it's a misprint? No, it says 81. Okay, I'm assuming that these things are root 3 upon 2s and things, and therefore all these various multiples add together to about 81 root 3s when they're finished. Because these are 5, 6, and they're going to get you answers, and these are 1, 6, and they're going to get you answers, and there's some kind of add and subtract, hopefully a whole load of negatives that turn into positives. And the whole total is allegedly 81 root 3. I guess I should try it. It's going to be negative 81k. What's the cosine of 5, 6 pi? Because it's a negative number, isn't it?
Negative square root of 3 over 2.
Okay, so we got that guy. Take away 9 times k, so I guess that's 45 6k. That's the first one. Then
There's a pi.
there's a pi. And this one.
You just have the theta, so it'd be 45 pi over 6.
Okay, sounds right. What's 1 6 going to get me? That's just going to get me positive square root of 3 upon 2. Take away 9 times k over 6 with a pi in it. So I'm going to get that guy with that guy, so that's positive. So I'm going to get 9 root 3k. I got this guy here, which just looks like an ugly fraction. This guy gives me a plus. I get another 9 root 3k. And this guy gets me plus 9k over 6 pi. Oh, I'm sorry. That's not the answer. The answer is to MK. The correct answer, because I was scanning the wrong place, is that one. MX, right, is that answer. So that's probably going to come out the way we said it is, because don't those two guys get you 18 root 3 with a k on it? And I'm assuming that these two play reasonably well together, and you get negative, God, don't have more, what do you get?
You get
Negative
negative 6k pi.
Will it be 6? It'll be 36 over 6, right? Which is 6, as you say. And then if you pull out, for some reason, they gave that as the common factor. You got one of these, and then you have to compensate to do that so that when you multiply it, it's that. So it actually does work. So the mass is that. When you come to do MX, at least on the version I've got, that was the answer that I scanned. And that ends up being that guy. Little guesstimate here. I know that shape's a total mess now, but can you imagine what it was like before I put all the radial lines and things on it? What do you think X bar is going to be just based on symmetry?
0.
It'll be 0. So if you're a gambling person, you could do that and save a bit of work, but I'm pretty sure it is, because the density function isn't lopsided. It doesn't make one side particularly different than the other. So that was those guys out the way. So to remind you, surface area, we're back to this fella. We are trying to calculate what the area on the surface would be when you've got, in this case, a region D on the ground. How do you look at that? Can you imagine that you had this very bright light made out of a triangle, and this was a kind of wobbly cloth, and you looked at above it? The area of that funny little triangle is called the surface area. Terence, do you have another question?
Yes, sir. So this
Yes.
formula, does it calculate the area of that surface as projected onto the onto the plane beneath it, or the actual area of the surface?
It's that guy up there, it's the blue guy. So we have a triangle on the ground, you project it up to the surface, it will make a kind of distorted triangle on the surface Z, and we're finding the area of that blue distorted triangle. So that's what we mean by the surface area in this question. Is that what you were asking?
Yes.
Okay, so that's what this formula will calculate. How many square inches, whatever the units are, that blue distorted triangle is. So if you're thinking of the projection, it's going up the way. Okay. Yes, no, maybe?
Yeah, sorry. The reverse of this process is how you get areas on map.
It wouldn't surprise me. Yeah. So 1, the surface. This is a version of question 1. The surface is essentially just a plane. And the rectangle D is described as using this notation. So if you want to find the surface area, so imagine you've got a diagonal plane, and on the bottom you've got basically a rectangle. Wouldn't it come up, wouldn't you basically just get a rectangle sloping? That's what it would look visually. And the surface area, I guess the area of the surface is how they pronounce it, is going to be the double integral of D of the first derivative squared plus with respect to x, partial derivative with respect to y squared plus 1 dA. If you wonder where the 1 comes from, it's actually the partial derivative of z with respect to z, so it gets you 1. So x goes from 0 to 5. Y goes from 1 to 8. Since I'm doing y first, I'll do y dx. If you differentiate partial derivative of this with respect to x, you get 2. The partial derivative of this with respect to y is 5, and 1 gets you 1. And we are basically trying to find
The partial derivative with respect to y. Oh, did I miswrite it down? Is that a 5?
it's a 5. So
Sure.
we are going, are we good? So we are going to
Yeah,
do
prove it.
25, 26, 430. So I make it the square root of 30. So if you want to find the surface area of this question, which is a rectangle on the ground, projecting upwards, making a shadow on the surface, the area of that shadow on the surface would be whatever this comes to. And I think we've done enough double integrals for me just to go a dot, dot, dot on that, and you could go and get it. I think it's easy to find, isn't it? Going to be 35 root 30 when you're finished. A bit quicker. Are we good with that one? I know I'm zooming through it, but are we good with that one? That's like a baby when he gets on the show. So next one that I'm going to look at is going to be an example where it's a triangle. And the surface is 13 plus x plus y squared. And the region D is described as the triangle made up from these 3 guys. Check, I got that wrong, it's a plus there. And this one is a negative there. So I'm going to draw that thing. If you go 2, 0, you go here. If you go negative 0, negative 2, you go here. Right, and where's the other one? And the third one's here. So this region is the D, right? The D that's going to go here. Okay, how do you want to do this one? Do you want to do vertical triangle, rectangles, so I can get the limits of integration, or do you want to do horizontal ones? You can actually do either in this particular case. Which one do you want to practice it?
Horizontal.
Oh, good choice. It's a little bit different. Let's go this way. Now, if you're scanning this way, aren't you going to go y equals 0 to -2? Right. Actually, let me do that again. -2 to 0, right? Don't you go from small to big? What would have happened if I'd actually done it the way I wrote there? What would we notice about our answer if everything else was done correctly?
The sign would be
It
flipped.
would be negative.
Right, but wouldn't the number be the same number? Right, so you would end up getting the same answer. So if that happens to you, especially in a homework question, well, you just change your -42 into 42 and you'll probably be fine. Now, the x's. Would you agree that the big one, right, meaning the biggest x is this one I'm pointing at with my little green guy, that's going to be 2, and isn't the other side of it that fella? Now, although it's going to be written down as x as a function of y, I'm actually going to do it as a y as a function of x first and then rearrange it. So if you take y equals, what slope is this line?
+1.
Okay, and would you agree, because its intercept is at -2, that is the equation of it. Now, since you want it kind of in a slightly different version, can you see that's what you get? Are you happy with x equals y plus 2? Now, to find the area of the surface, it's going to be the integral from y equals -2 to y equals 0. The integral from x equals y plus 2 to x equals 2. And then it's going to be the square root of this guy differentiated with respect to x, so you get 1 squared. This guy, you're going to get 2y squared plus a 1 dx dy. Now that's going to give me the integral from there to there. It's going to give me the integral from there to there. And then I'm going to have to do 2 plus 4y squared dx dy. I didn't know this was going to happen till you told me, Tessa. When you know how you've got a choice, you can do the vertical or the horizontal. Sometimes, and this is a good example of it, would you agree that the square root of 2 plus 4y squared is going to be really easy to integrate with respect to x? And probably really ugly when you do it with respect to y. But that's okay. Now, if I'd switched it the other way around, right, if I'd done it the vertical way, you may get it. If once you've finished this lit, right, because basically isn't it going to be that ugly guy with an x attached to it, right? That's all you're going to get. Can you trust me that you get something like this? Right again. It's going to look something like this when you get to the next guys. And I'm going to let the alphabet we on anyway. There we go. It's going to be something like this when you get to the y's. How are you going to integrate that? It might be a multiply, it might be 2 of these, it might be half. That's basically what it's going to look like. How are we going to finish it?
U sub.
It's going to be a U sub. Now, I suspect strongly if I went vertical, I'd get the same situation. But sometimes, because this might be one of the sometimes, if you do the integral one way around, couldn't the integral be really horrible and really messy? But if you did it the other way around, it ends up being really nice. So you might want to have a shot at trying it the other way, just in case the integral comes out nicer. I'm not saying it will. I don't really know because I haven't done the other way. Gut feeling is it's probably going to be just as bad. But it can be worth it just to have a look. The reason why I think it might be different is, see how that's an x, but this is a y squared? I think that might make a difference between which direction is going to be nice and which is not. So if someone gives you a triangle, are you happy about how to set it up, because that's as far as I'm going, dot, dot, dot. So I think what we need to do now is we need to look at an example of what is also a triangle, even if it doesn't look like it. And we've been asked to find the surface area of this thing that lies in the first octant. This is just a visual of what's going on. Do not pay any great attention to it. Can you imagine that the plane is diagonally going like that? Right. Okay. So it's going to cut the X, Y, and the Z axis. So there's going to be a little bit of this triangle, right? It's going to exist in the XY plane. So what we need to do is we need to figure out, what does this triangle look like that's then going to get projected upwards and distorted in some way because it's on the plane. I wish I was a good artist. So here we go. This plane is going to cut the is going to cut the X, the Y, and the Z axis at 3 different places. If you take the equation, you can find out these numbers, where it cuts those axes. For instance, if I wanted to, which I don't need to, if I wanted to find out where it cut the Z axis, you make those two 0 and it happens at 65. Right. So far, so good. Now, if you take this plane and you make this guy 0, because that's basically what it would look like if it thumped to the floor, you would get this guy. And if you look at this guy and you make him 0, you get X equals 13. If you make him 0, you get Y equals 5. That tells me that's 5, that's 13. It's in the first octant, so that's the only bit I want. We have now found D. So if you get an equation of a plane equals a number, and it's the first octant, this is how we're going to do it. We know that it's going to make a triangular shape because it's the first octant, so the origin's guaranteed. And all we're doing is we're finding out where this plane cuts the X and Y axis. And we're doing that by making this 0, and then selectively, basically, that's the equation of my line. And in fact, since that is the equation of my line, if I do a little bit of rearranging, isn't this going to be a rather ugly, that guy. So this is going to be Y equals -15/3 X plus 5.
Negative.
Question.
Oh, -5/3.
I heard something that sounded like -5. I didn't catch the rest, Sally.
For some reason, I thought I heard you say -15/3 instead of -5/15. My bad.
Oh, right. I may have said it. I'm not aware of. I can hardly remember what I had for my dinner. Right. So I want to set up this region D then, and I'm just going to go with vertical. And so what does that tell me? It tells me X goes from 0 to 5, and that Y goes from the bottom, which is 0, to that line, which is -5/13 X plus 5. And so the area of the surface is going to be this integral from X equals 0 to X equals 5, from Y equals 0 to Y equals the straight line. The square root of the derivative of this function with respect to X squared, the derivative of this function with respect to Y squared, plus 1. And then we'll do a dy and a dx. that would become from 0 to the straight line. That's 169, 170, and then 25, 205 it looks like. And at that point, I'm just going to do my dot, dot, dot again, because we've got the integral pretty much set up. And it's just the usual double integral. Do the y's first and then plug in 0 and 5 with x's second.
Excuse me, sir. I'm
Yeah.
having problems with that y equals negative 5/13 x plus 5, because you plug a
Okay.
0 into that and y is equal to 5, not 13.
Oh, you are right. Have I got my guys back to front? That's possible. And I have, but thankfully the equation is correct. That's 13 and that's 5. So I just drew them on the diagram wrong. So the equation is fine. See, it does cut the 5.
So then doesn't then the double integral need to go from
0 to 13? Yes. Are we good now?
thank you, yes.
Yeah. Well done.
And for the square root, it should be the square root of 195.
I'm glad you lot are awake. The good news is you know what the heck is going on, or you wouldn't be correcting me, right?
No, I was just confused. I didn't know what was going on.
No, you were helping me. But I think by now you always should be double checking anything that I do. The quicker I go, the more mistakes I make, unfortunately, but that's life. I want to do one last question, and I want to do one that has got polar coordinate situation, right? So I'll just make up my own. I'm going to have to adjust the homework to kind of accommodate the fact that we didn't quite get everything done. That wasn't anyone's fault, just the way it is. Here is Z, and the region D is, well, let me draw region D. And region D ends up being this guy. And they might give you a picture, or they might describe it as inside a little big circle, outside a small circle, and the x-axis. Now, when you look at this region D, would you agree that it lends itself really well to polar? And when you look at the Z, would you agree it also lends itself much better to polar form? So, although the surface area formula is described in terms of this, and we will have to, you know, do this at least superficially with x's first. But once that's done, we can bring in the polar. So let's talk, in fact, slightly out of order, but I think it works. If I was describing this region in polar form, wouldn't the r and the thetas all be numbers? Right? What would the r value range in this dome-shaped kind of structure?
3 to 5.
3 to 5. Would you agree that the theta goes from 0 to pi? Okay. Now, right now, I'm just going to call that D. I'm not going to put X's, R's, or anything. Just call it D. And so I can take care of this fella. Now, if you differentiate this guy, you get negative 2x. And if you differentiate this guy, you get negative 2y squared. And you get a plus 1 dA. So that's going to be a double integral over 4x squared plus 4y squared plus 1. Are you okay about all the negatives when you square them just become positive? Things like 4x squared. Are we good so far? Right, now it's time to make everything polar. We've already set up the limits integration. So theta can go from 0 to pi. R can go from 3 to 5. This is going to be the square root of, if you take this guy and you call him r cos theta, you get 4r squared cos squared theta. And the other guy, you get 4r squared sine squared theta plus 1. And won't the dA just turn into an r dr d theta? Still with me? Now, you've hopefully seen enough of these kind of things to know that they actually simplify relatively well. What will this horrible mess look like when you simplify it down?
It'll be 8r squared plus 4.
Right? 4 or 8? How many r squareds?
8.
Are you? If you pull out 4r squared as a common factor, don't you just get cos squared plus sine squared, which is 1? So you still end up with 4r squared. I'll write it at the side. If you take 4r squared,
Alright,
squared
but there'd
here.
still be the plus 1.
Yeah, there'll still be a plus 1, you're right. So I'm pulling out 4r squared, and I'm leaving those two terms. Those are 1. There, do you see it's not 8, but 4? We good? But it's worth checking with me, as you know. And that r that was there, I'm going to stick it here. Right. How are you going to integrate this guy?
That looks like a good friend to you, Sub.
It is. In fact, isn't this one variable separable if you wanted to do it? So you'll do a 4r squared plus 1, you plug in some numbers, you'll have a theta from 0 to pi, well, just 1 d theta, so that's going to get you pi. I think, I don't know what the answer is, but it's going to be some horrible version of 2 square roots all multiplied by a pi, I'm assuming. But it's a dot, dot, dot. So make sure that you have got your last name for attendance. And I won't be able to get to the last homework to take out some questions which will add to next week's work, but I will keep most of them in there. And the test will be due on Sunday midnight, but don't even go near it yet. Not that I think any of you would want to at this present moment, because I'm going to have to go in and take a couple of questions out from surface areas, situations we haven't covered yet. Right. So if you don't go near it until tomorrow. That'll give me plenty of time to do that. And probably don't do the last homework till at least sometime this evening, so that you don't end up doing questions that you don't know how to do or shouldn't be able to do. Right, last name, bye-bye. I'll hang about for any questions.
Have a good weekend.
You too.
Thank you,
Have a good
Mr. Robertson.
Right.
I just had a quick question about
Sure.
the midterm.
Yes.
It's going to be held during normal class time, so it's like a 50-minute midterm.
No, it should be a bigger time, so it's a 2-hour slot. It's in the syllabus somewhere.
Oh,
So
okay.
it's going to be added. You're a bit of flexibility. You can either start at 10 and then finish at 12, or you can start at 11 or finish at 1. But you will need 2 hours to do it. It's worth a lot of points, and it also takes a lot of time. So you want that extra window.